All right, so picking up where we were yesterday, we had just finished working with our multiplication properties and rules with integers. So we're just going to be continuing on from that, the second half of 2.4 material, working with division of integers. So our rules with that, some very important rules that do come up with certain numbers that we can or can't work with. But we're going to start with just going through a few things with that, and we'll go from there. So if we are going to be using division of integers, for determining the sign of an answer, again, it's very similar to what we worked with multiplication. So if I have a mix of positives and negatives, how do I determine if my answer is going to be positive or negative in that regard? So we're going to use, again, very similar to what we did above. We're going to let A and B be values. Then A over B, which is also implied to be A divided by B, results are the same as multiplication. So again, if I have, we can use the table from our stuff that we did yesterday. We're assuming A and B are values. Determine for yourself, is A positive or negative? Is B positive or negative? We follow the same rule of thumb for going through determining the sign of our final answer. And again, specifically, the sign of the final answer, not the actual value of it. So again, our general rule of thumb that we went through yesterday, and we can apply the same thing for our division problems instead, or as well. If the signs are the same with division, then the result is positive. If the signs differ from one another, one's positive, one's negative, doesn't matter which one, then the result is going to be negative. So again, this is working particularly with the sign of our final answer. Is our answer positive? Is it negative? General rule of thumb that we have there for that. So I'm going to move us over to the top of our next page. So when you are given a fraction, we'll use 24 over 3 as an example, it is always implied that the numerator is being divided by the denominator. So when we have this written out, I'm just going to scroll us down here a little bit. Still, you're going to use 24 over 3 as the example. So when you are working with a problem on the homework, when you're working something out on your own, that's very bad too. Let's make that a bit better. There we go. These two things are equal to one another. They are the exact same statement. So if you are starting with something written as a fraction and you want to rewrite it out as we're starting with a fraction, I don't want it written like that. I just want to do division instead. You could write it in that form. That's fine. Maybe you have something that's written out starting as 24 divided by 3. You say, well, I don't want to have a bunch of extra signs or operations going on in that problem. You can rewrite it into a fraction form, which I like doing quite a bit because I think fractions get a bad rap. They're actually very helpful as we go through and solve these things. So I just want to make a note of that because a lot of people think fractions and division are two completely different things, and we have to work with them completely differently from one another. And really the only time that's true is based on which form we write it in, either as a fraction or as division explicitly. But you're more than welcome to go back and forth between either of these two forms as you see fit. And I recommend getting comfortable with doing that as necessary, these problems. So, get rid of this down here. So, the big one that I do want to mention and go through, this is a very big deal and it's not a particularly subtle or not particularly obvious scenario or result that we get, and it's division by 0. So if A is an integer, it could be positive, it could be negative, it could be anything. Think of your favorite number. Then A divided by 0 is undefined. It's not infinity, it's not negative infinity, it's not 0, it is undefined. We fundamentally do not know the answer to this question. There are some theories about what the answer could be, but we do not definitively know what the answer is. So I'm going to go through an example with this So follow along with me in your head, and then I'm going to go through with a really nice visual. I think that helps with demonstrating this. So we have 12 boxes. Say you're carrying them from upstairs to downstairs, moving things around, something like that. Okay. So following the scenario, we're going to have 12 as the numerator. We're going to have differing numbers as our denominator. Now in your head, tell me, how many trips is it going to take me to move these 12 boxes if I move 12 boxes at a time? So it's going to take me one trip. 12 divided by 12, it's going to take me once. Okay? So how many trips would it take me if I take 6 boxes at a time? It's going to take me 2. How many trips will it take me if I take, let's say, 2 boxes at a time? That's going to take me 6 trips. How many trips will it take me if I take 1 box at a time? It's going to take me 12. Now we're going to get a little weird here with this, but follow along with the same. How many trips would it take me if I only took half a box at a time? Well, it's going to take me 24 then, because each box is going to take me 2 trips, and I've got 12 boxes total, so I'm going to have 24 then. Okay. So as we're seeing the smaller and smaller amount of times that we're going through and smaller number of boxes that we're taking, the larger number of trips that we're having. So now we'll go with the weird one. How many trips would it take me to move those 12 boxes if I took 0 boxes per trip? And if you're sitting there thinking, I don't know, it doesn't make sense. Exactly. Because we don't know. We could go back and forth between upstairs, downstairs, once, twice, 500 times, 10 million times, 5 billion times. We don't know how many times it's going to take us to move those boxes then. And that's where we get this definition of dividing by 0 as being undefined, because we don't know how long or how many times it's going to take us. Okay, so I'm going to show you guys a nice visual that we have with this. We're going to jump over. I'm actually going to get this set up here before we get to that. Oops. Okay, so let's jump over to Desmos here. Sorry, just bringing this up, loading it here really quick. Okay. So we're taking a slight detour from our main material. Again, I just want to emphasize the division by 0 part here. This is Desmos.com. It's a free online tool that you can use for doing a lot of great graphing work. It's a pretty intuitive, pretty straightforward site to operate. You have your equations on the left-hand side. You've got your axes and everything that shows up over here. So we're going to create a visual of the scenario that we just worked with. So I'm going to type in an equation to represent this, and then we'll kind of go back through what we just did. One scenario. So I've got 12 boxes divided by X many trips that we go on. And already we're getting kind of weird looking stuff showing up. So X is going to represent our number of boxes we're taking per trip. And Y is going to represent how many trips we're taking total to move boxes from upstairs to downstairs. So if we look at our scenario here, okay, let's work with the one where, what's our X value? So when our X value is 12, it took me 1 trip. Okay, so that's matching up. When our X value is 6, it took us 2 trips. Our X value is 2. Okay, it's moving over here. When our X value is 2, it took us, come on, can't get it just right, 6 trips. Our X value is 1, which is somewhere up here. It took us 12 trips, and so on. Now, notice as I get closer to having 0 trips, what happens? Well, it keeps going up, and that number keeps growing, and, well, kind of still see that red line there a little bit, and it keeps on going up. So looking at this, you could be thinking, well, couldn't that go up to positive infinity, way, way up there? And theoretically, yes, it could go up to positive infinity. However, this is the really weird part. Looking at division by 0, what happens on the other side? As we looked at this part of the graph, we looked at this part of the graph. But now, what's this one doing? Well, it's going down, 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 all the way to what would be negative infinity. So the question is then, okay, well, positive infinity seems reasonable if it's going up. Negative infinity seems reasonable if it's going down. Which one is it? And we don't know. We don't definitively know what the final answer is going to be with this. So this is another, it's kind of a roundabout way. This is another reason as to why we have any division by 0 is undefined. Because we don't know which of these two scenarios we're working with. And more importantly then, well, okay, what is infinity? It's a concept. It's not exactly a number. So we don't have an exact raw definition of it in that regard also. So multiple reasons why we can't have a defined answer when that sort of thing shows up. So jumping us back to our notes here. And again, the main reason I wanted to go through that with you guys is because I see it very often. If/when this shows up on a test, hint, hint, I get a lot of people who get to this scenario or this point of the problem and then say, oh, it's 0. And no, it isn't. It's undefined. You will need to write out or write in undefined for your final answer. If you just write in 0, you have a wrong answer and you're going to lose points for that. So there's a very big difference between nothing and 0 and undefined, I should say. So let's take a look at a couple of these examples that are listed here. Just for the sake of taking a look at them and seeing our process as we go through it. The main reason I want to go through these is because I think sign analysis and being able to keep track of, is my answer positive, is it negative, as we have multiple things multiplying together is very important to do. So keeping our work organized on that front. So I'll go through each of these really quick. So we'll jump on over to the whiteboard. Okay. So we are told to simplify. And again, simplify should be your buzzword. What am I going to be doing when I'm simplifying? I'm going to be using PEMDAS. PEMDAS in the order of operations. So our first example that we had, on the other page, we have -9 times 4, better 4. There we go. Times -2. Now, yesterday we learned about the associative property, which tells us we can group these things together any way we want to, meaning I could choose whichever two of these that I want to multiply together first and then go through and do that. So I could multiply the -9 and the 4 together. I could multiply the 4 and the -2 together. It's your choice. I'm going to work with -9 and 4 just because they're at the very beginning there. So -9 times 4, a negative times a positive is going to give me a negative answer. So before I do the numbers, I can just write out for myself, I'm going to have a negative. And now 9 times 4, that's going to give me 36. I've not done anything with the -2, so I'm just bringing that down. And now I have -36 times -2. A negative times a negative is a positive. And then 36 times 2 is going to give me 72. So I'm getting positive 72 for my final answer. If you know your final answer is going to be positive, you don't need to write in a plus. It is assumed that the number that's just written is 72. It's assumed that that is a positive value. Okay, so looking at our second example from that same page. Just move this over here a little bit. More space. And -2. Okay. So we have a lot of things that are multiplying together here. And again, if you're someone who can multiply all of this together, or like multiply 2 or 3 things together in your head at once, great, good for you. I'm not one of those people. So take the extra time if you need to again, do these in parts. So I'm going to do a very similar process to what we did yesterday. I'm just going to go with the first 2 values, and then we'll go with the next 2 after that, and so on and so forth. But again, taking this thing in parts, not trying to do it all at once, because that goes a really long way with these, if we can kind of break these things down. So just working with 2 times 7, positive times a positive, it's going to give me 14, or positive 14. Nothing else is changing in the problem, better 3. So I'm just bringing the rest of it down as it was. And again, for me, as I'm going through this, I'm just going to work with the first 2 and multiply those together. So I have a positive 14 times a negative 3, working with the sign first. I have a positive times a negative. My answer is going to be negative, so I'm just going to put that in. And now we do 14 times 3. I'm going to apply the calculator because I don't know what that is off the top of my head. It's going to be 42. So again, I think it's really nice to differentiate between let's figure out what the sign is and then let's figure out what the number is, because that's really helpful. And again, the same thing, just working with the first 2 here. Put this up a little bit. So I have a negative 42 times a positive 4. So a negative times a positive is going to give me a negative answer. 42 times 4, again, applying the calculator, it's going to give me 168. Nothing happened to the negative 1, nothing happened to the negative 2. It's just coming down. And again, working just with the first 2 terms there, I have a negative times a negative. That's going to give me a positive answer. And then anything times 1 is just going to be itself. That negative 1 multiplying through is just going to change the sign of the answer. And then I have a positive 168 times a negative 2. Positive times a negative is going to give me a negative answer. And then 168 times 2. Again, apply the calculator if you need it. It's giving me 336. So I'm getting negative 336 for my final answer. And I'm done. Okay. So a couple examples we had there with multiplication. We'll take a look at a few of these with division. So again, going from that same page, we're just going to work with our third example that we have there. We are still simplifying. So 24 over negative 8. So again, this is written out as a fraction, but it is implied that we do have 24 being divided by 8. So if you want to, you could rewrite this thing for yourself as 24 divided by negative 8. I'm just going to make a note of this here. This is optional. So again, you do not need to do this. If you can look at the original thing that we have been given, and you know that that is the numerator divided by the denominator, and you want to work with it that way, great, go for it. If you're someone who says, yeah, it's a bit easier for me to look at it actually written out as a division problem and working with it that way, great, go with that also, whatever works for you. Regardless of whichever method you want to use, we do have these 2 things dividing. So I have a positive 24 being divided by a negative 8. So again, looking at our signs first and foremost, positive divided by a negative tells me that my answer is going to be negative. Signs are different from one another. And now, what is 24 divided by 8? That's going to give me 3. I already have the sign figured out, so I can just write in my answer there. The value right there. And we get our final answer of negative 3. So we'll take a look at our last one, because I think it's one of the trickier ones that shows up with this. Just because of the double signs again, which are just always a pain, I think. but we do want to go through them to at least know how we work with them. So we have negative 120 divided by negative 6. Excuse me. So first and foremost, we could look at this and say, well, I've got double signs showing up here. I have a negative here and I have a negative here. So we could actually work with the signs here and now before we actually go into doing any numerical calculations. So for the sake of seeing how that works, let's go through that. So I have a negative divided by a negative. That's going to give me a positive answer, which means whatever 120 divided by 6 is, I'm going to have a positive answer from that. So my next line of work, I can just cancel out and not have those negatives in there. I can rewrite this instead to be 120 divided by 6. I know my answer is positive. This is now written as a positive divided by a positive. So that's going to give me a positive answer, and I'm good to go there. The signs are gone, and now I can just worry about doing 120 divided by 6. And you can apply your calculator if you need to for that. You should be getting an answer of 20. And we have that there. So these are the 4 examples that we had at the very end of our lecture notes here. Try and get these all on screen because I know some people like taking screenshots of these. So try and get that available to you guys there, either for now or for the recording later. But this is all of the 2.4 material. So working with multiplying and dividing integers. Again, I think the signs are one of the biggest parts that come out of this section, and division by 0 is another really big one. So making sure we're working with that properly. Again, I think division by 0 is a more common occurrence in 2.5 over anything else, but it's worth noting that now, so when we get to and take a look at that in the future, we are at least a little bit familiar with what this should or shouldn't be looking like. Okay. So with that, let's, I'm just looking at our time here. Let's at least get started on maybe one problem from 2.5, just to get some work in it, or a preview of the types of problems that we have coming out of this. So we'll jump us back to our notes we have here. Okay, so it's 2.4, and we'll go over to 2.5. So 2.5 has us working with the order of operations with integers. And order of operations, it's still PEMDAS. Nothing is changing on that front. Nothing is changing on the process that we are going to be using. So all of the previous notes that we had for working with order of operations with PEMDAS in the past, it's the exact same thing. Nothing is changing at all. Okay. The only thing that we have that we're now adding in, we did work with the absolute value sign. So we need to make sure that we are using that correctly. And I did put a note in here for you guys as well. Remember that the absolute value signs have the extra property of making the value positive after rewriting the absolute value signs as parentheses. So we treat them just as if they were parentheses. So simplify everything inside the absolute value sign first. And then after we have a single value in there, then we are going to apply the actual property of the absolute value sign, which is to make that value a positive number. Everything else though, exponents, we work with the same way, multiplication, division. Again, rule of thumb is to go left to right if you're not sure what to do. Addition, subtraction, same thing. Rule of thumb is go left to right if you're not sure which one to do. And then we just have more advanced, kind of gross looking problems that are showing up with this. But each and every one of these are going to be utilizing PEMDAS to go through as a step-by-step process for solving this. Okay. So looking at our time, we're going to try and get through at least, we'll try and get through these first 2 examples, nothing else. And then we'll call that there. So I'm going to jump back to our whiteboard to go through both of these examples here. Let's move us down here and zoom in a little bit. Come on. There we go. Okay. So we're working with 2.5. So our first example that we have, and again, we are told to simplify. So again, the buzzword showing up. I'm told to simplify PEMDAS, order of operations. That's exactly what we should be going to with all of these. So rewriting that thing out. So we have 4 times the quantity of 4 minus 2, all to the second power, minus 7 times 10 minus 7. Okay. So again, if you're someone like me, who've got a lot of stuff going on in here and you need to write out PEMDAS for yourself off to the side, do it. You want to keep your work very organized as you're going through these types of problems, because it's very, very easy to get lost in what you're doing and lose track of where you are, what you're doing next, and make this problem significantly harder for yourself than it needs to be. So again, the first thing in PEMDAS, parentheses. So I'm going to work with just what I have inside my sets of parentheses. And what's going on inside those? Well, I don't have any parentheses inside them. I don't have any exponents inside them. I have no multiplication or division inside them. I do have addition subtraction going on though. So I'm just going to work with what's inside the parentheses. I have 4 minus 2. It's going to give me a positive 2. I have 10 minus 7, which is going to give me 3. Everything else that was not inside that set of parentheses is staying exactly the same. I've not gotten to it yet in PEMDAS, so I'm not going to be applying anything with it. Do not skip ahead in that regard. A lot of people try and say, well, I'm going to do the parentheses and I'll multiply stuff together and maybe I'll apply that exponent all at once. Don't do that. If you're not comfortable with the PEMDAS process, do not skip ahead in the steps. You do that at your own peril, essentially. So from our checklist, parentheses are done. So good there. Next thing, exponents. Well, I have this 2 up here, so I'm going to apply that. I have everything inside this set of parentheses being raised to the second power. So I have 2 to the second power, which is going to give me 4. Nothing else is happening, so nothing else in the problem should be changing. And now I'm done with exponents, so I can check that off. I have multiplication happening. I have 4 times 4. I have 7 times 3. Let's move this up here a little bit. 4 times 4 is going to give me 16. I have negative 7 times 3. Negative times a positive is going to give me a negative. Okay, negative 21 there. So my multiplication division is done. I just have addition subtraction. 16 minus 21. That's going to give me a negative 5. I can't do anything else. I just have a value. So I'm done. Okay. Now I do want to go through that second example on that page because it does have the absolute value sign showing up, and I want to make it very clear how you work with the absolute value signs with these things. So our second example, we have negative 9 plus the absolute value of 2 squared minus 3 squared. And when you're writing these out for yourself, make it abundantly clear that these are vertical lines. I've seen a lot of people kind of quickly write something out and it's like, well, okay, is this thing a parenthesis? Is it a absolute value sign? We don't really know. And a lot of people get that mixed up for themselves. So make it abundantly clear for the absolute value signs in your problem as you are writing it out for yourself. So again, we're working with PEMDAS. So get rid of that. Come on. Sorry, I've got a zoom pop-up that's showing up there. There we go. Okay. So again, first things first, parentheses. And we treat everything inside, or we treat the absolute value sign as though it were a set of parentheses. So when we have a set of parentheses, we go inside those first, and we restart PEMDAS all over again. So looking inside the set of parentheses, or the absolute value sign, I have 2 squared minus 3 squared, which means I have exponents going on. So I need to work with those exponents first. So I'm going to apply 2 squared minus 3 squared. So 2 squared would give me 4. Better 4. There we go. Minus 3 squared is going to give me 9. Just putting that there. And now I'm still not done inside those absolute value signs because I can still do subtraction. I'm still looking inside here. I'm just going to do 4 minus 9. That's going to give me a negative 5. And now I cannot simplify anything else inside this absolute value sign. And at this point in time, now that I have just a single number in here, now is the time when I can apply the property of the absolute value. So what is the absolute value of negative 5? It's going to give me a positive 5. Again, it's that distance from 0. And when we apply that, we can instead make this thing a positive value, and then if you want to, I think this is helpful, write this thing out explicitly inside of a set of parentheses instead. Make that 5 a bit better here. So I applied the absolute value sign. I now have a positive answer there, and I can check off the parentheses. So my parentheses are done. Do I have any exponents? No, so I'm done there. Multiplication or division? No, done there. Addition, subtraction, I have a negative 9 plus 5. So I'm going to work with that. Negative 9 plus 5 is going to give me a negative 4, my final answer. I can't do anything else from there. So I am done. Okay. So again, the steps, big one to note, is right here. We only apply the absolute value property when all that's left inside is just a single value. You cannot apply it up here. You cannot apply it up here. You can only apply the absolute value signs property when there's a single value inside of that absolute value sign. If there's anything else in there, any other operations that you could do, you cannot apply the absolute value property. And if you do, you are going to lose points on it because you're going to get a wrong answer. So the absolute value property is the last thing you do in the PEMDAS step, or the parenthesis portion of the PEMDAS step, I should say. Okay? And again, I cannot emphasize that enough because it's a very, very common error that occurs when people are going through and using the simplification process and an absolute value sign in there. Okay? So I'm looking at the time here. I am going to end the recording there, and I'll open it up to you guys if you have any questions about the examples that we've gone through so far. We are going to continue on and do more of these specific types of examples, more of 2.5 on Monday, but I did want to get us at least a preview of what this is going to look like for Monday and a preview of what these types of PEMDAS problems are going to look like on the test. Yeah, so we'll end the recording and we'll take questions from there.